There's a good chance you're already familiar with relational databases and SQL and databases like MySQL, so let's find out how that intersects with the world of Hadoop. We can actually make your Hadoop cluster look like a relational database through a technology called Hive, and there's also ways of integrating a Hadoop cluster with a MySQL database. So let's talk about both of those topics in this next section. Let's talk about Hive. It's a very powerful and very simple way of querying data across your Hadoop cluster that just uses the power of SQL, the structured query language. What is Hive? Well, it lets you just write standard SQL queries that look just like you'd be using them on MySQL or something, but actually execute them on data that's stored across your entire cluster, maybe on an HDFS cluster as well. And it works by actually translating your SQL into MapReduce commands or TES commands, depending on what you want to use. And that just runs on top of the Hadoop Yarn cluster manager to actually execute your stuff. So basically, it will break down your SQL query into mappers and reducers and figure out how to tie them all together and actually execute them across a cluster automatically. So from your standpoint, this looks just like querying a SQL database, just like using any other data warehouse. So it's really, really powerful stuff if you're already familiar with SQL or you're coming from a database or data warehouse world. Why would you use Hive? Well, again, the familiarity of it is the main key. So if you already know SQL, and that is a structured query language that's used for querying relational databases like Oracle or MySQL or what have you, a lot of people coming into the world of big data have some prior experience in those sorts of realms. So it allows you to leverage that knowledge to become very quickly productive using a Hadoop cluster. It's actually called HiveQL, which is its variant of SQL, and it's very similar to MySQL syntax. So pretty much anything you can do in SQL, you can do in HiveQL, with a few exceptions that we'll talk about in a bit. It's interactive in nature, so you can actually bring up an interactive command prompt with HiveQL and actually, type select statements and stuff just like you would with a normal database. It's scalable. And so, the real power is that it can actually work with data that's distributed on an entire cluster of computers, unlike a traditional database where typically you're restricted to what you can fit on one single host. So think about it as a powerful tool for data warehouse types of applications where you're trying to issue a query on a very large data set. You don't expect it to come back immediately, but you will get that answer back within a reasonable amount of time, and it can actually scale far beyond what you could do on a single database instance. So we're talking about OLAP queries, online analytics processing. So, it's a lot easier to do this using Hive and SQL syntax and actually writing the equivalent MapReduce in Java. I mean, if you look at the actual lines of SQL code that you need to actually do something useful versus the lines of Java code you would need to write a MapReduce job to do the same thing, we're talking like an order of magnitude more simplicity here. And again, it's for online analytics. So, if you're trying to do like real-time transactions, not the right match, but if you are trying to do, analytic queries across a large data set, that's where Hive shines. Highly optimized for what it does, and it's highly extensible too. So if SQL isn't enough for you, you can actually plug in your own user-defined functions. You can plug in your own explicit mappers if you want to. And it also exposes a thrift server, so you can actually talk to Hive from a service outside of Hive itself. And it actually exposes a JDBC and an ODBC driver to make Hive look just like any other database to you. So lots of ways to extend Hive and lots of ways to work it into other systems as well. Why would you not use Hive? Well, again, it's for OLAP, not OLTP. OLTP stands for online transaction processing. So if you need to, some sort of high throughput, low latency sort of situation, Hive isn't going to cut it. Remember, it's just going to be translating your SQL commands into MapReduce jobs, and MapReduce jobs take some time to spin up, right? So, you shouldn't be issuing a ton of requests through Hive at the same time, and you shouldn't be expecting to get a result back, in less than a few minutes. But, when you're dealing with massive data sets, it's going to be a lot more efficient than the alternative and, in fact, make some queries possible that wouldn't be possible otherwise. Also, keep in mind, we're dealing with denormalized data here, so it's not a real relational database under the hood. It's just flat text files. So even though you can query things kind of pretending that it's a relational database, it isn't really. So under the hood, everything's denormalized. You're not going to have like separate tables that are like joined, through foreign keys and things like that. So, if you don't depend on that behavior, if that's something you're used to from the relational database world. SQL also has its limits. If you do need to do more complicated queries, then something like Pig or Spark might be more appropriate, although you can chain these commands together. We'll talk about that through views. And some important limitations. It's not a real database. Remember, it's just MapReduce under the hood, so you don't have any transactions. There are no record level updates, inserts, or deletes because under the hood there are no real database records to begin with. It's just big flat text files that you're chugging through with mappers and reducers. And Hive is basically a bunch of smoke and mirrors to make it look like a database so you can issue SQL queries on it. But it isn't really. Now, the variation of SQL used by Hive is called HiveQL. Like I said, it's pretty much the same thing as MySQL. That's the closest relative that it has in terms of syntax, but it has some extensions that are specific to Hive. One of those extensions is views, and we're going to look at that in our example coming up here. And that's kind of a powerful thing. You can actually store the results of one query into a view, and then use that view as a table in subsequent queries. So it's a way of breaking up more complicated queries into individual queries that kind of build on top of each other by developing these views. It's not quite the same thing as a materialized view in the database world. A materialized view actually stores copies of the data, but a view in Hive is more of a logical construct. So that logical construct of a view will persist, but it's not actually storing a copy of the data anywhere. Okay, so a little bit of a subtle difference there. Also, HiveQL has a bunch of extensions to allow you to specify exactly how the data you're reading in is structured and stored and partitioned, and we'll talk about that in more detail later on. But by and large, anything you can do with MySQL, you can pretty much do with HiveQL, again with the exception of things like record level stuff. So with that, let's just dive right into an example. It's going to make a lot more sense if we just take a look at how to actually use this puppy. So let's do that in our next lecture.